Okay, one final parting idea about flux integrals. So I'm just going to assume that I have some surface chilling out in 3 space, right? So here's my surface. Maybe just for, okay. Just for ease of drawing, I'm going to go like this. I'm going to say my surface is some chunk of a sphere. This is not a better surface. You guys all see my sphere? So I just took a chunk of orange slice, right? And then skinned it, and I stuck my little rind in space. And now, what I need to check first off is that there's a consistent choice of normal vector. You guys see this? Okay. So I'm going to pick like that way. You guys see this? Okay. Okay, so my consistent choice of normal vector is going to go like this. You guys all see this? Okay, so I'm going to think there's also some ambient vector field going on. Maybe my vector field goes like this. You guys all see this? Okay. Like, so I've got my sail and the wind behind it, right? Or my net's in the water and the water's flowing through this net, right? So I'm trying to calculate the total flux. So let me draw another surface here and we'll think. So like here's the surface, right? What if your vector field looked like this?
No flux.
Yeah, it doesn't seem like there's any flux at all, right?
It doesn't even intersect the surface.
Yeah, but I mean it's everywhere, right? So it's kind of doing this. Yeah, but it doesn't seem to go through it at all. You guys see that? Like, if I drew flow lines, none of the flow lines would actually go through this thing. Yeah. So, when I want to calculate a flux, right, I'm going to say, all right, I'm going to approximate this the same way I approximated a line integral, right? So I'm going to do, okay, so the flux through my surface S with my vector field F, right, is going to be about, let's see, so,
The sum of all the...
yeah, you'd like cut this thing up, right? So you're going to cut this thing up into some pieces, and then you're going to get what? You're going to add up.
Well, it's how much they agree between the ambient and the normal.
Okay, so how do I figure out the ambient and the normal? How do I figure out how much 2 vectors agree? A dot product them, right? So I should take F and dot it with...
Area vector.
Yeah, okay, so I need a normal vector, right? To see if they're pointed in the same direction, right? So I dot it with the normal vector, and then I need to weight everything by...
Area of the surface.
Yeah, by how big the patch that normal vector represents is. You guys see that? You guys with me on this?
Okay.
Okay, so this is what you're going to take for today. The thing you're going to take for the idea of normal vectors, or for the idea of flux integrals, is that the surface has to be orientable. And then the things you're looking for are the agreement between the flow, right, the vector field, and the normal vector. And then you're going to weight everything by the area of the patches on which that's happening. You guys see this?
Okay.
So like here, right, my sphere is going to have normal vectors that point either out or in.
Yep.
Right? Depending on whether I'm answering what's the flow out of the sphere or into the sphere.
Which is why that currently has a dot product of 0.
Yeah, this guy dots to 0, right? So I'm going to say the flux here is 0. And the flux there is going to be
1 probably.
Yeah, at least positive, right? If the vector field flowed the other way, or if I picked my normal vector pointed this way, you would get the opposite answer, right? You guys all cool with that? And that's going to be really the net flow. You guys see that? Because this one's all positive and this one's all 0, but it's possible that we could do like sphere and flow that just does this, right? This is going to net out to 0, right? You guys see that?
Yep.
It's not saying there's no flow through the sphere, it's saying there's no total flow. Because there's flow in and also flow out. You guys good with that? So it's signed just like line integrals. Cool?